You know what they say, tomato, potato.
It's tomato, tomato.
Well, I mean, tomatoes are the reason we have potatoes at all.
Well, wait, what?
A study just came out today that wanted to look at how potatoes evolved, well, they're potatoes, the little tubers at the end that we eat, which has actually been a mystery for a surprisingly long time.
Because a lot of close cousins to potatoes, like Et tuberosum, look like this, with not a tuber in sight. There's nothing here that I can dip in ketchup. It's tuberosum.
So then how did potatoes evolve the starchy goodness that we all know and love? Well, after conducting what the authors called, quote, the most comprehensive collection of wild potato genomic data ever analyzed, incredible, they found that the missing genetic puzzle piece was crossbreeding from millions of years ago with tomatoes, which, if you didn't know, are also a close cousin of potatoes and Et tuberosum.
Wait, but tomatoes don't have tubers either.
Well, that's the funny thing about genetics. See, tomatoes have the SP6A gene, which makes it possible for the plant to start growing tubers. But Et tuberosum has the IT1 gene, which is responsible for growth of underground stems. It's only when both of these plants happen to naturally crossbreed an estimated 9 million years ago that both of these genes were turned on in a plant that would eventually become the potato.
Ooh. Hey, you got tomato genes in my tuberosum genes. And you got your tuberosum genes in my tomato genes. Now Wait, did we just make French fries?
And it also, became one of the most resilient and energy-dense crops on the entire planet that, without exaggeration, changed the course of human civilization.
Yeah, I'd argue that's the more important of those two things.
Well,